Okay, this is another example of a seesaw, but this time we've actually got two masses on one side. Okay, and when the seesaw is in equilibrium, again the seesaw would be horizontal. Okay, so these two objects here, if they were on the seesaw by themselves, the seesaw would turn in this direction, the same direction that my pen's turning, and so that's the clockwise direction. So therefore that's the clockwise torque is going that way, and therefore this one is your anti-clockwise torque. Okay, now just one thing different here, so I'll just keep writing the pivot point in here, it's here. Okay, just so you know, it's in the centre there. We measure from there when we're measuring distances, and we also have to measure in standard international units. So the distance between the 4 kilogram mass and the pivot point is 0.35 of a metre. From the pivot point to the first little oval, it is 0.2 of a metre. But between the pivot point and the second little oval, it's 0.4 metres. So it's this 0.2 plus the 0.2. I haven't written it in there because it's got to be the distance from the pivot point. Okay, so the first part is calculate the clockwise torque. So we've got to add two things together here. So I'm going to do this one slightly differently because you might like to do it this way. It would be 2 times 9.8, that gives you the weight force, times 0.2 metres, plus, I'm going to put all that in a bracket like that, plus, again, 2 times 9.8, but this time we have to multiply that by 0.4. Now the reason we do it by 0.4 is because this second egg here is 0.4 of a metre away from the pivot point. Now if you've used lots of brackets, you can put that all in your calculator in one go, and you would get 11.76 Newton meters. I'm just going to leave it at 4 sig fig for now, just to see, because we just the way the questions work. So part B says calculate the total anti-clockwise torque. So that is your 4 times 9.8 to turn it into a weight force times 0.35. And that is equal to 13.72 Newton meters. And the third question says, is the system in equilibrium? No, it is not. So in reality, that seesaw would not be sitting like that. It wouldn't be sitting horizontally. And the anti-clockwise torque is larger. So that means the seesaw would actually be doing that, okay, in that kind of position, because this torque is larger than this one. So this mass here is providing more of a turning effect. So it would turn more, okay, than this one. So it would be sort of sitting on a lean like that. Okay, so hopefully you can work your way through that one.